Our next session, the last before lunch, is a panel discussion on the challenges for implementing in-use monitoring programs. Moderating our panel is Mike Pankinen, Senior Director, Technical and Safety Standards at the Association of Equipment Manufacturers. Mike has been in technical and safety issues services at AEM since 2007. And for the few of you who probably don't know this, based in Milwaukee, Wisconsin, AEM is the trade association that provides services on a global basis for companies that manufacture equipment, products, and services for the agriculture, construction, forestry, mining, and utility industries. AEM's membership is made up of more than 850 companies and represents in excess of 200 product lines. Mike will introduce his panelists, many of whom you recognize, so welcome, Mike.
Well, thank you, Mike, and thank you to Integer, and also to all of the different people who are sponsoring the program. So some of the stuff that I would want to comment on today to start with is really a reiteration of much of the things that have already been said. AEM does represent, now it's over 950 OEMs, over 250 product lines. And those range from the largest of mining trucks, big as a two-story house as we know, to some of those things that are small handheld or things that people walk behind. So there's a vast difference. Some of our OEMs are the large multinationals. Others are small regional OEMs who maybe only sell in one part of the country or maybe have just one niche product. The point being, some of the challenges that we have heard from our three former speakers are all things that will impact the in-use testing. Harsh vibrations. I took note of the one photograph of the Ripper machine. You can imagine the vibration that puts into a product. Or machines that actually do intentionally vibrate, as an example, compaction machines. Some machines are in a constant state of motion, and Bill made comments that other machines spent the bulk of their time just waiting for maybe a very short period of time when they're actually being used to some level. Thank you, panelists. I'm not going to go through the full bios that you did before, but I would like to bring again to your attention Bill Robertson with the California Air Resources Board, been there for 11 years. We also have Dan Carter, Director of the West Virginia University Center for Advanced Fuels, Engines and Emissions, CAFE, with 25-year history, and then Mike Kennard, Engineering Director of AVL Powertrain Engineering, with 22 years in powertrain development. So to start our discussion, Bill, can I direct the first question to you, and that is, I'm going to go back to the real kindergarten question, okay, which again may be so far below your experience, but I think it's good to start that as leveling. Provide a Cliff Notes version of in-use testing procedures for the U.S. heavy-duty on-road, because it's not being done in off-road at this time. How is it done? If you could give us a guidance.
Get this thing to turn on. It says push. Oh, okay.
Yeah, just speak.
Dan's got a green light. Got confused. Okay, so the heavy-duty in-use testing program. Better? Is that better? Okay. So the heavy-duty in-use testing program is a manufacturer-run program. It's based on using portable measurement equipment. My agency and US EPA tend to coordinate a little bit each year to decide which engines we're going to ask for. And then we send a list of engine families to the manufacturers and ask them to perform in-use testing on those engine families. And so then they have to go out and find a fleet that has their product in that engine family, and then they have to test a certain number of vehicles, and it's kind of staged where if they test the first certain number of vehicles and pass, I think that's the 5, then they're good, and then there's the stage, if one of them fails, maybe there's some incremental thing to try and conserve testing burden for passing products without, and then having a sort of a recourse if there is an early failure, to make sure that it isn't just a one-off situation. That we're looking for is the product performing on a population basis, but we're trying not to test every single one of the population. So they get a fleet partner, and then they go out there with this portable emission measurement system, which is about 500-600 pounds of equipment. That AVL ably provides a system. Horiba has a system. Sensors has a system. But it measures all the criteria pollutants. It measures PM. It can measure exhaust flow. There are a couple of ways you can get that with ECU data or inferred from fuel, carbon balance from the exhaust, or declared values from the ECU. And then as Dan was talking about, you have to capture all of that instrumentation data, capture that ECU data, capture the ambient data, and time align all of that, and then this thing gets set up and sit out on the road with just the normal driver doing his normal route, and then when it comes back, you cross your fingers that it all, none of the wires came loose, and then there's a post-processing to look for these applicable NTE events, and then there's a criterion for how many of the events can fail before the vehicle fails, and then that whole data set then gets reported back to the regulatory agency, the second-by-second data, the post-processed reports, and the information on the vehicles and vehicle selection. So we've had close to 6, 7 years, 8 years of this data being reported back. So we think it's highly motivating to the calibration engineers. There's been some creativity that the manufacturers have that seem to have in their some of the fleets that have been tested. There's a requirement for 3 hours of non-idle operation to guarantee that there's sufficient activity in the duty cycle chosen. So we've gotten some data submitted where they got a bucket truck or something that it had 3 hours of non-idle, but there was no way it was going to hit the minimum power requirement. There's some temperature limits, and so there's some limitations to the NTE program as covering all the emissions of all of the activity of the vehicle, but we think it's been a very useful program, and it's gotten people thinking in a different way about calibration, and it was created largely out of the consent decree, as Dan was mentioning, and we think it's served very well in that purpose. But now that AVL's done such a good job of making these boxes, these emission collection boxes that you can carry out in the field, everyone gets curious about what's all the rest of the operation look like, and what's an appropriate metric to look at that. So is that sufficient summary of kind of how
For me, that's good. How about that? I'll direct the second question to Michael. Given the difference between the on-road, which we've heard about repeatedly this morning, and the off-road operating conditions, what additional challenges do you anticipate in developing an effective in-use testing procedure, and how would they impact the testing? And specifically some things, the quality of the fuel, DEF quality, the impact of the duty cycle, even the impact of the operator or the sensitivity of the test equipment, amongst others, I'm sure.
Okay. So I think to start with, a speaker yesterday said that the prime purpose of an on-highway truck is to move goods, whereas the prime purpose of a off-highway machine is not. Therefore, there isn't naturally somewhere that you can put this equipment in the off-road market. So if you take construction equipment, agricultural equipment, when they design that equipment, they don't package protect for 500-600 pounds of equipment that you've got to carry around with you, especially very sensitive equipment. So at a fundamental, there are basic challenges that have to be overcome when you do this testing. And the challenge is when you apply these systems, these very sensitive systems to these type of applications, you need to do it in a way that you're not influencing the results that you're getting. So to your specific question about how does that influence the setting of a future regulation, the standards as they exist at the moment do define quite carefully how you should go about a measuring principle. The challenge is ensuring that that's realistic on the wide range of applications that are out there. So there may need to be some flexibility in approach of how you actually collect that data. So then on to some of the other specific off-road market challenges. If you look at fuel quality and DEF quality, as you said. So firstly, fuel quality. Fuel quality is a challenge both on and off-road. The issue is really the likelihood of coming across low-quality fuel in the off-highway road market is much higher. But the current on-road regulation allows for you to get the fuel tested prior to or after the testing has been conducted if you find issues with the results. So that mechanism exists already, and the same can be applied for DEF quality. So onto the operating and the duty cycle of the application. What you may find if you apply the same testing methodology to the off-road market is a lot of test time but very little valid test data, because these machines may spend a lot of time at idle, a lot of time where it's operating outside of the envelope that would be a valid PEMS event. So the challenge there is making sure that you're measuring effectively to determine the real emissions output of that engine without biasing the result.
Would anyone else have some comments on? Are you all in agreement? Okay.
I would just add that we're looking at these NTE events and the scarcity of them, and on the on-road, they're actually engine families that are certifying by default because they went 8 hours, didn't see any events, so there's nothing to pass, fail, evaluate. So we're interested in revisiting what the structure of an in-use evaluation tool would be, because from our perspective, we're an agency that's tasked with public health, and the aspect of public health that's due to the air quality in an air shed. And so it's kind of, what did this vehicle do for a shift that matters to the air shed? And so whether it's idling or working, or if it's running, that's what is its effect is kind of what affects our end goal as an agency. So we're interested in looking at a compliance tool that looks at a little, if the vehicle's idling, but that's kind of how it operates for the shift. We're interested in something that might look at that region as well. So, we'll be thinking about the on-road portion of that a little more specifically next week at our workshop, and there may be opportunities to enhance the off-road in-use testing as well.
Next question I'll direct to Dan. During one of the presentations we saw where one engine was used in multiple applications. Could you comment on what would be the statistical parameters that you would need to validate a test? Would they be different? I think we saw 5 and 10 as some of the typical test numbers that are utilized. To have a statistically valid test, as you understand the off-road industry, would those numbers change? And what would be the impact of machine population on those statistical numbers?
I mean, first, I think there needs to be a separation of validation of the test itself versus validation of the, say, engine family from a compliance standpoint. The validation of a test in and of itself, there's a number of checks and balances that one can use that everyone probably already uses. So, a carbon balance looking at reported fuel consumed or actually measured fuel consumed to largely CO2. Of course, if you want to throw HC and CO in there, that's fine. But that gives you at least a pretty good, at end of day, when you're holding the flashlight over the data, trying to see whether or not you can move on. And I think that's one key issue to look at. And that's why I think that, as OBD requirements increase or get more, more encompassing in terms of numbers of sensors, where Leo was saying kind of let's make this blind testing, as I pointed out in the presentation, I think you still want to bring that data in because it's very good to validate the data that you're independently measuring. From a vehicle statistic standpoint, I don't think you're ever going to get to a statistically representative sample of an engine family. I mean, I think if you do that, we're going to test so many vehicles that will never do anything but test vehicles. I don't know that Bill kind of hinted on the phase one, you did a minimum test of 5 and you worked your way up to 10. I think if you did 5 and 6 and you passed, you didn't have to go to 10. And that was less than 25% of the engine families in a given certification year. Then phase 2, you did kind of 10 vehicles, and we could look into more in depth of maybe what the vocation was, and maybe what what the operators look like, what ambient conditions look like. So, I think as much as number of vehicles, more variability in the types of vocation, and the location of vehicles is important as well. So ultimately, I think we'll probably end up in similar numbers. Is that significant? I would say that it's probably a reasonable approach of being representative, never to the true statistical significance, I don't believe.
Good, thank you. Michael, this is again fairly broad, but what principles would you apply to develop a test procedure for off-road testing, including the hardware, to achieve accurate and repeatable results across that wide variety of equipment and duty cycles?
So I think we've probably touched on this already, but it's really following the same fundamental principles that are there. The test equipment is defined. The measurement equipment that's required to capture the emissions that we're talking about exists. The test procedure is going to be basically operating the equipment as it would operate naturally and collecting that data. I think the challenge is more in how you go about analyzing that data in order to make a judgment on the emissions level of the equipment. But fundamentally, you're going to be taking the measurements over the normal operation of the equipment.
Any other comments from the panel?
I think Bill kind of touched on it, and again, what's the goal of the end-use testing program? I think we really need to define that first. If it's truly just to define, just to catch the occasional defeat device, I think your principles and procedures look completely different than if you're actually trying to gain valuable insight into what these technologies are doing in the real world, how they're helping with a state implementation plan, for instance. And that volume of data then is different than the volume of data you want to use for compliance. So, even though there are exclusions or things that are provided for, I think being able to see all of that operation, and Bill gave it a good example of a family of vehicles that couldn't be assessed one way or the other just because there wasn't sufficient operating points met. there's still very valuable data in not even in a compliance, from a compliance standpoint, but just from a modeling standpoint of, I think probably in 25 years, the value of everything that I've done is probably most in that area, is that supplying that data for people to assess, what does our pathway look like and what's our predictions now look like compared to what it was before we implemented this technology.
Thank you. At this point, rather than my going on, I think it's good. We're getting close to lunch. Could we open it up to questions on the floor?
Anyone?
Is that a question back there?
No?
I don't see any. Okay, well, at that, thank you, panel, and we appreciate, again, the opportunity. So I believe we're pretty close to on time, aren't we? Thank you.